Today we get to talk about significant digits. Let's get started. Non-zero digits and zeros between non-zero digits are significant. So this means this 4 is significant, and the 5 and the 3, those are non-zero digits, and zeros between non-zero digits are called significant. And so this 0 is between two significant digits, so it is significant. So what we are doing is we're just counting how many significant digits we have, and we get 4. For the next one, we have a 3 and a 5 and a 7. But all of these zeros are between significant digits, so we have to count them all. So 1, 2, 3, 4, 5, 6. Likewise here, 1, 2, 3, and 4 and 5. These are all significant. 1 and 2, and all of these zeros in between are significant for a total of 1, 2, 3, 4, 5, 6. So that's the first one. First step, you have to know that non-zero digits are significant and zeros between non-zero digits are significant. Step B, zeros to the left of the first non-zero digit are not significant. Okay, so these zeros appear before a number, so they are not significant. So we have 1, 2, and 3 significant digits. Zeros here not. Here we have just 2 digits, 2 significant digits. We cross out that. 1, 2, 3 significant digits. All of these zeros are not significant. So we have 1 significant digit. Step C. Zeros to the right of a non-zero digit and also to the right of a decimal place are significant. Notice that these zeros are at the end of the number and to the right of the decimal point. So we would have to count all of these zeros as significant digits. This one and this one and this one are significant because they are non-zero. This 0 is significant because it's between two non-zero digits. And these 2 zeros are significant because they are between non-zero digits. And this 0 is significant because it appears at the end of the number and to the right of the decimal place. So all 7 of those are significant. Here, these zeros are not significant. And this one and this one and this one are. And this 0 is significant because it appears between two significant digits. And this 0 is significant because it's at the end of the number and to the right of the decimal place. Okay, 990.000. Well, we know these 2 zeros these 2 nines are significant. But these zeros here, this 0 is at the end of the number and to the right of the decimal place. So you know it's significant. That automatically qualifies all of these other zeros as significant. So we have 6 significant digits. Zeros to the right of a non-zero digit and to the left of a decimal place may or may not be significant. This gets a little tricky. You see, this 3 and this 4, these are significant, but this 0 is not. Yes, it is at the end of the number, but it is not to the right of the decimal place. It is to the left. And notice we don't even have a decimal point. So if there's no decimal point here, you know that this 0, this last 0, is not significant. Now, let's jump down here real quick. Notice that this 0 has a decimal point right after. Because it has a decimal point right after, you know that it is significant. So you know that that's significant because it has a decimal point. So because you know it's significant, zeros between significant digits are significant, and we have 4 significant digits here. Likewise here, this 0 is at the end of the number though, so it's significant, And because it's significant, that automatically qualifies these two. But this 3,400 up here, notice this 340, there's no decimal point here. So if there's no decimal point, this zero, this last zero, is not significant. Notice that in 3,400, we know that this zero is not significant right here. We know it's not because there's no decimal point. But 3,400, this zero here may or may not be significant. We don't really know. We know that there's at least two significant digits, but this one here, this zero right there, we do not know if that's significant or not. And so if we were to determine how many significant digits there are, we always err on the side of caution here. We always go and say there are two significant digits in this number, but there may be three. You know, if we had 3, 4, 0, 0, 0, now if we look at this, we know this digit's significant. We know this one is, but there's no decimal point over here. So we know that this one is not significant. But we don't know anything about these two numbers. They may or may not be significant. So we could have two significant digits, three significant digits, or four significant digits in this answer. We don't know, because when you write a number out in an expanded form like this, it leaves some ambiguity, which is why what we do is we like to put things in scientific notation. And you might say, oh my goodness, this scientific notation keeps creeping up. It sure does, because it's important. You see, we can use scientific notation to specify how many significant digits there are. You see, we could say this is 1, 2, 3, 4. We could say 3.4 times 10 to the fourth. See, we have 1, 2, 3, 4. 3.4 times 10 to the fourth. And then we would know that there were exactly two significant digits. But I could write this number as 3.40 times 10 to the fourth. And then we would have three significant digits, 1, 2, 3, because the zero is at the end of the number and to the right of the decimal point. Notice that by writing something in scientific notation, we get more information about the number and how many digits that it's significant to. See, I could write it like this, times 10 to the fourth, and that gives me another significant digit. So writing things in scientific notation sometimes is a lot more meaningful to us looking at numbers and how significant those numbers are. Well, I hope you like that. See, scientific notation really is an important thing to understand, and so and also numbers and their meanings. You know, what does it mean 3.4 is different than 3.40? Well, or 3.400. You know, we have more information about the number. Let me give you an example. Let's say that we were to buy some silver and the silver was 99% pure. So that would be 0.99 pure. Sometimes we would call this, you might see it called 2N or 2 nines. It's 2 nines pure. So 2N. But what if I had something that was 99.999% pure? Well, that's a lot more significant right here, because you're saying 0.999999. You know, there's a total of 5 nines there, so we'll say 5N, 5 nines pure. Now, if you were to buy this, you know, you're going to pay so much money for this silver that's 99% pure. But when you buy silver that's 99.999% pure, 5N pure silver is going to cost you a lot more money than just 2N pure, because we've gotten all of those other impurities out. We know when we made the measurement, many more of the impurities were removed. And so This is moving closer towards a pure grade of silver. So significant digits tell us a lot about what we have when we do our measurements. They tell us a lot. They help us quantify our measurements. How accurate are those measurements? You know, what value can we get to that? Or if we wanted to measure something, how precise can we measure them? You know, how precise is our measuring device? So then it leads to these two words, accuracy and precision. And so I'll get into that in a second, but I want to do a couple more quick things. I wanted to say, if we had something like 7,500, and I put a decimal point there, and I asked you to write this to the correct number of significant digits in scientific notation, I would hope that you would just say 7.5 times 10 to the third. 7.5 times 10 to the third. And you might think, well, wait a minute, that's not right. Why is that not right? Well, because we have 1, 2, 3, 4 significant digits here. And then my answer here is only 2. So we wouldn't be able to say that. We would have to say 7.500 times 10 to the third. Notice now we have 4 significant digits here, and we have 4 significant digits here. So I wanted to say that one more time because I wanted to give you another example really quickly before we moved on. Let's see. You know, I might want to do another quick one too, like this, like I say, 99,600.305. You know, if I put like a 00 at the end of that and said write this in scientific notation, you might say, okay, well, it's 9.9600.305, and we may have a tendency to drop off these other 2 zeros because we might not think they're important, but we know from our previous statements that they are significant. So we cannot neglect them. We have to include those in our answer. Times 10 to the 1, 2, 3, 4, times 10 to the fourth here. So I would have to write all of that out. Don't neglect those 2 zeros. They are significant because they come at the end of the number and to the right of the decimal point. Now, if I had something like 99,600, if I just had this, then you would just say 9.96 times 10 to the fourth, right? 1, 2, 3, 4. Because we don't know that these zeros are significant. There's no decimal point here. This 0 may or may not be, but we don't know. So we make sure that we would just say 9.96. Okay, so let's move on to accuracy and precision. And the best way to do that is with dartboards. So let's imagine that we're playing darts and we just throw our darts everywhere. If we just throw our darts everywhere, notice that we didn't hit the target and our darts are not close together. Because we didn't hit the target, we have very low accuracy, because we didn't hit the target. And our darts are very far apart, so we have low precision. So low accuracy because we didn't hit the target, low precision because our darts are far apart. Notice if we play the dartboard game again, we take this, we didn't hit the target, so again we have low accuracy. But notice all of our darts are in the same position. That gives us very high precision. They're all really, really close to each other. Low accuracy, high precision. These are how we make our measurements. Okay, so here's the other two. What's happening? We didn't hit the target, but what's happening here? We are getting closer and closer to this accuracy. We are getting much more accurate than we were before. So the accuracy, we're always hitting right here, all in the same spot. So our accuracy is better, but our darts are very far apart yet. So we have low precision. So we have higher accuracy, but low precision. Our darts aren't, they didn't hit the target, that's correct. But their accuracy is a lot higher than it was in the previous examples. So we're always right inside that center ring. So we're higher accuracy. Maybe we could say higher accuracy. But notice if we get the actual target, if we hit the actual target, we are very accurate. We have high accuracy, but also precision. Notice the darts are very close together. We have high precision. So when we're making measurements, accuracy and precision, how accurate are our measurements? How precise can we make our measurements? How many significant digits can our measurements have? These are all things that we need to consider. So significant digits are very important. So go over the rules, do the homework, and then perform the quiz. Have a great day.